Okay, A, B and C are points on a circle K. O is the centre of the circle and OBA is 15 degrees. AB equals AC, OB equals OC equals BC. Calculate OBC and give a reason for your answer. So I'm just going to quickly revise what I call the Star Trek sign rules. Anybody know this rule?
Star Trek.
So basically, if you have an arc AB, does everybody know what the arc is? You have a circle and AB is the arc. Is everybody alright with that?
Yeah.
Now, if I make an angle with this arc to the centre of the circle, is everybody happy with that? Yeah? And then if I make a similar angle with a third point on the circle, no matter the location of that point, when you join up the arc AB to this third point, we usually call that O, we call that C. What will result is that this angle here is half of the angle underneath. So if I was to give you an example, if this was 120 degrees, what would that make the top one? 60. Is that okay? So I call that basically, if you want the technical language, is that an angle on the arc AB that links into the centre of the circle to form the angle AOB, and there's another angle for a third point C that lies on the circle, such that the angle ACB is half of OAB. Just explain it using your own words, no point trying to learn off all the language. Okay? Happens every time. Now there's a second rule I went with the other day. Does anybody remember this one? It's basically, if I have the centre of the circle there, and I have once again an arc AB, okay, what can people tell me? I'm about to draw two angles, okay? We call that point C, this one point D, and what I'm going to do is going to draw two angles. So the first one will be a green angle, and the second one will be a blue angle. Can anybody tell me the relationship between the green angle and the blue angle? What does it look like? Okay, now why are they the same? Both angles are standing on the same arc. So first of all, point C and point D are both points on a circle, and you notice that the beginning and end points of both angles are, it starts at A and ends at B, and the second one starts at A and ends at B. Means every single time that happens, both angles will be the same size. Everybody cool with that? Now, if we go up to the diagram above, we're going to use some of these rules to calculate this. Now, the first thing it says is calculate OBC. O to B to C. Well, it says that all three lengths are the same. So what does that mean? It's an equilateral triangle, which is 60, 60 and 60. What does that make? And then it tells me that this angle in here is 15. That makes that angle 75. Yeah? Now, so we have a isosceles triangle that's 75, 75, and what does it make the top angle? 75 plus 75? 150, take away from 180 is 30. And that also confirms our theory about this angle being half of that one. Everybody right with that? Okay. Now, question 15. B is the centre of the circle. Radius is 4.5. Sorry, excuse me. 4.5. Okay. T is a point on the circle. P to A is 3 centimetres. Can anybody tell me what P to B would be then? 7.5, because you're going to add on a radius, aren't you? So that makes that full thing 7.5. Can anybody tell me, the whole point of the question is to find out what P to T is? We'll call that X. What type of triangle am I dealing with there? Is it a...
Right angle.
How do you know for certain it's a right angle? It says the word tangent. A tangent is a line that hits its equation of a line at one point only, and it has to go 90 degrees. So that's 90 degrees there. Yeah? What's the longest side? 7.5 squared equals x squared plus 4.5 squared.
How come x isn't the longest side for this one?
Well, if you took a ruler out, it wouldn't be. And it's opposite, it's the one that's opposite the 90 degrees is always the longest one.
Oh yeah.
So, if you aren't sure, you can always just measure it using a ruler and you can figure out which one's the hypotenuse that way. Does a hypotenuse exist for a triangle that's not right angled? No. Hypotenuse only exists for right angled triangles. That means x equals 6. Everybody cool with that? Just Pythagoras' term. Moving on to 17. Okay, starting to make our way up here. Okay, the next rule I went over with you the other day was this rule here. That's the centre of the circle, yeah? Can anybody tell me what a chord is? A chord. Starts on a point on the circle, ends on a point on the circle. A secant is one that goes straight through. Okay? So starts here, ends here. Now, there's a special rule about these, okay? And the rule is this. If I have 2 points A, B, yeah? I have a point A to a point B. Everybody happy enough with that? If I find the midpoint, yeah? Where the midpoint will be? There, yeah? What happens if I join the centre of the circle to the midpoint? What type of angle do you think it's going to make?
90.
90 degrees. So basically, if you get the midpoint of AB, draw a line perpendicular through the midpoint, it always has to go through the centre of the circle. Is that alright with you?
How do you find the midpoint?
It'll give you coordinates, or each question will give you enough information to find the midpoint, or somehow use that rule I showed you there to do whatever the question's asking you to do. So look at this question as an example. It says O to M is 7. It then says A to B is 48. What do you think that makes A to M? 24. The whole point of the question, A to M is 24 because the midpoint divides the length in half. What is the length of the radius? The radius. So what you need to do here is just draw this. What type of triangle is that here? Right angle triangle. It's an isosceles. The whole triangle itself is isosceles, but we can divide it into two right angle triangles then, can't we? Everybody knows that when you have an isosceles triangle where two sides are the same length, would you agree with that? The midpoint of the other line will always be directly underneath the tip of the triangle itself. So hence you can make two right angled triangles. This is no different. So which is the longest side this time, Sean?
X.
X is the longest side, so it's going to be x squared equals 7 squared plus 24 squared. X squared equals 625. X equals 25. Driving on? Yeah. Okay. 23. Couple of circles, looks a bit confusing. Okay. Circles A, B and C have a radius of 24, 10 and 6. The centres P, Q and R respectively. They also touch each other externally. Show that PQR is a right angled triangle. What rule do all right angled triangles obey? There's a rule out there that only right angled triangles obey. SOHCAHTOA, that's one set of rules. Another rule? Pythagoras' term only works for right angled triangles, no other type of triangle. So you look at this here, and what I might do is I might draw a line from this one to this one, this one to this one, this one to this one. Which one looks like the right angle? QR, P or PR, Q. That looks like the right angle. Okay? Can anybody tell me the distance from P to Q? P to Q? It's 24 plus 10. Dan, do you put your bag down?
Yeah.
So you can look at it. What we have here is 24 plus 10 is 34. Can anybody tell me this distance here? Sorry? 30, is it? It's 24 plus 6, which is 30. And then the other one? That's 10 plus 6, which is 16. We're just adding the radiuses together. And then, will this obey Pythagoras' theorem? But somebody just tell me what 34 squared is in the calculator. I think it might be 1156. That's what I'm hoping for.
Yeah. It's 1156.
Thank you. Since it obeys Pythagoras' theorem, because it's obvious 34 is the longest length, 30 and 16, because it obeys Pythagoras' theorem, it's guaranteed to be a right angle triangle. Is that alright? Now, done. 25. PA and PB are tangents to the circle O. PO intersects the circle at C and D. OA is 5. What does that automatically mean then? It means OD is 5. OD and OC are also 5. And it says PC is 8, doesn't it? So how far is O to P then? Huh? 13. Gotta be 13. Okay? Give a reason why OAP is 90 degrees. O to A to P. Does it say it's a tangent? PA is a tangent and OA is a radius. Tangent is always perpendicular to the radius. Everybody got that?
Yeah.
Radius, tangent. Makes a T. See that T? It's like a T. That's what it's called, tangent. Okay. Now, calculate A to P. We already calculate that as 13. Write tan OPA as a fraction and evaluate what OPA is. Which triangle does OPA belong to? OPA. Which triangle would it belong to? Will it not belong to the triangle OPA? Yeah? It's an easy question. If you have an angle, it generally belongs to the triangle that all the letters belong to. What type of triangle is OPA?
Right angle.
So O to P to A is a right angle triangle. What else is there then? That's 5. That's 13. And now we want to figure out what?
Pythagoras.
Oh, sorry, we had to figure out what AP is. I haven't figured out AP yet. My fault. My fault. I didn't actually figure out what AP was earlier. I actually used the answer for OP. So we can use Pythagoras' theorem here, can't we? 13 squared equals x squared plus 5 squared. You'll find out that 144 equals x squared. X equals 12. Okay. Now, when you're asked an angle question, guys, would you use Pythagoras' theorem to answer an angle question? What's the only way to answer an angle question? Sine inverse, cos inverse, or tan inverse. Okay. Now I have all three sides, don't I? And which angle am I looking for? O to P to A. I'm looking for that angle there. So any suggestions? Call it angle A if you want. So we can do tan A equals 5 over 12 for opposite over adjacent. What else could we do? Cos A equals, what would cos A be equal to?
Doesn't that tell you to use tan?
Oh, does it tell you to use tan? Yeah. I was just saying you could use other ones. You could get 12 over 13. Wanted to use tan. Shift tan inverse 5 over 12. The angle in question is 22.62. degrees, okay? Hence, calculate the following correct to nearest degree. It wants you to calculate the angle AOP. What's AOP? Let's get rid of all this for a second. It's 23. Where's the AOP? Down there, so 90 plus 23, 113. Take away from 180. 67. ADP. A to D to P. An interesting one. Now lads, this is a very interesting one now. You just gotta be able to see it, okay? This is 67. Would you agree that that triangle got cut in half? Got bisected, didn't it? Because that line there goes straight through the centre, straight to the other side. It's going to be bisected. Two tangents, got to be bisected. Okay. The two triangles are congruent to each other. Look, same length, common length, radius. By SSS, both of those triangles are congruent to each other. Okay. So, if I was to show you a little trick here. If I was to turn this upside down, we're looking for this. We're looking for the Star Trek rule, the Star Trek sign in a roundabout way. We're looking for A to D to P. Okay, stand this down. So it's hard to spot. See it there? This angle here is twice that angle there, and in turn, if that's 67 by 6, if that's 67 and 67, this means that full thing is going to be 67. It's 134 divided by 2 is 67. That 67 in turn gets halved and makes the angle ADP. That's A to D all the way down to P. What is that angle in there? 33 and a half.
So why was angle D 67 again?
I found out that AOP was 67.
Yeah.
AOP was this one here.
Yeah.
And because it's congruent to this one here, they're both 67.
Yeah.
And using the Star Trek sign rule, where I basically say that this angle here is double that angle there.
Oh, yeah.
So that would make this full angle here 134, which makes that one there 67. Then I halved it to get 33.5. Because the 67 degree angle is in two different parts. It's in two different halves, the top half and the lower half. And I'm asked for ADP, which is the lower half. Okay.